Can flies fly backwards? A deep dive into insect aerodynamics. Have you ever tried to swat a fly only to watch it dart away in the opposite direction, sometimes seemingly backward? You're not alone in wondering, can flies really fly backwards? Or is it just an illusion caused by their lightning-fast movements? This simple question opens the door to a fascinating world of insect flight biomechanics, aerodynamics, and the evolution of survival strategies in one of nature's most resilient creatures. Do flies really fly backwards? Yes, some species of flies are capable of flying backwards, albeit in short bursts and under specific conditions. While forward flight is the default for most insects, backward flight has evolved in certain species as a survival and navigation mechanism. Flies don't fly backwards the way a hummingbird might hover and retreat gracefully. Instead, it's often a rapid and reactive maneuver, enabled by their unique wing mechanics and neuroprecision. Evidence: scientific proof of backward flight. High-speed videography. Researchers at the University of Cambridge used high-speed cameras up to 7,500 frames per second to study hoverflies, Syrphidae. In these recordings, they observed the flies performing rapid directional changes, including brief but deliberate backward motion during evasive or reorientation behaviors. Reference: Collett T.S. and Land M.F., 1975. Visual Control of Orientation in the Hoverfly, Journal of Comparative Physiology. Neurobiology and Wing Control. Flies have independent wing control on both sides of their body. Each wing can adjust its stroke amplitude, stroke frequency, angle of attack. This allows flies to manipulate thrust direction in real time. The halteres, tiny gyroscopic organs, provide balance and orientation feedback, enabling them to perform complex 3D maneuvers, including backward escape movements. Reference: Dickinson, M.H., etc., 1999. How Flies Fly, Scientific American. Flight simulations and robotic mimicry. Flight simulators and robotic insects designed by MIT and Caltech have replicated fly-like movement. These robots needed to mimic short reverse thrusts to stabilize or evade, mirroring what real flies do. Reference: Wood R.J., 2008, the first flight of a micro-robot powered by micro-actuators, IEE transactions. Why would a fly need to fly backwards? Evasion from predators, including you. When you raise your hand to swat, a fly's compound eyes detect motion nearly 360 degrees around, and its brain processes the threat in less than 100 milliseconds. Backward flight helps it instantly break forward momentum, buy time to reorient mid-air, avoid linear traps like a flat surface or hand, precision in landing and hovering. Flies often hover before landing, especially on walls or ceilings. Backward movement allows them to abort a misaligned landing or correct approach angles with surgical precision. Mating displays and territorial maneuvers. In species like hoverflies, males perform backward swoops during aerial dances. These serve both to impress females with control, ward off rival males. Mid-air recalibration. Backward movements sometimes occur when flies are disoriented by wind, light, or obstacles. It's part of their sensory motor feedback loop, a built-in correction mechanism that helps them regain balance and orientation. The hidden artistry of fly flight. So, can flies fly backwards? Absolutely, but it's not their primary mode of travel. It's a specialized, short-duration, high-precision maneuver that reflects the evolutionary sophistication of these tiny but mighty creatures. Backward flight in flies is mechanically possible thanks to wing independence and halter feedback, observed in nature and laboratory conditions, purposeful, often used for evasion, repositioning, or courtship. The next time a fly escapes your hand in reverse, don't get frustrated, admire it. You're witnessing micro-aeronautical mastery honed over 65 million years of evolution.